All right, today we're going to dive deep into the world around us, inside our industries, and yeah, even inside our own homes. We're going to uncover a tiny but absolutely crucial component that's preventing disaster every single day. So let's jump right in. You know that sound, right? You shut off a faucet, or maybe the washing machine stops, and then all of a sudden, bam! There's this loud, jarring bang that just echoes through the house. It's a pretty unnerving sound, for sure, but it's way more than just noise. It's actually a warning sign. That banging has a name. It's called a water hammer, and here's what's happening. Think about all that water moving through your pipes. It has a ton of momentum. When a valve suddenly slams shut, all that energy has nowhere to go. It instantly creates this powerful, high-pressure shockwave that rattles everything. And this isn't just an annoyance. This is a seriously destructive force. So at the very heart of this problem is something called backflow. It's basically fluid trying to rush backward the wrong way. To stop this chaos, you need a pretty simple but elegant solution. You need a one-way gate, something that lets things flow forward but automatically slams the door shut if they try to reverse course. And that right there brings us to the unsung heroes of this whole story. They are the gatekeepers, the silent guardians working inside our pipes to prevent all that chaos. They're called check valves, or sometimes you'll hear non-return valves, and their job is beautiful in its simplicity. They work automatically, opening up to let fluid go one way and snapping shut to block it from flowing backward. There are no handles, no external controls, it's just pure, simple physics doing its thing. And look, they might be small, but you really can't overstate their importance. These little gatekeepers are absolutely essential for the safe and smooth operation of some of the biggest and most critical systems on the entire planet. I mean, just think about the oil and gas industry. Check valves are what prevent reverse flow in those high-pressure pipelines. They're protecting incredibly expensive equipment, things like compressors and wellheads, from catastrophic damage. Or how about power plants? They are just as vital there, helping maintain system pressure and making sure steam and water only flow in one direction. That's pretty fundamental to making electricity safely and efficiently, right? And this one really hits home. In our water treatment plants, they're doing more than just protecting equipment. They're protecting us. They stop contaminated water from flowing backward, which ensures the quality and safety of the water we drink every day. Okay, so not all check valves are created equal. You can kind of think of them like characters in a play. Different types have their own unique designs, their own strengths, and of course, their own weaknesses. And that makes them suitable for very different roles. So let's meet the main players. First up, you've got the swing check. This is the old classic. You know, it's simple and it doesn't block the flow much, which is great. But, and this is a big but, its slow closing speed can be its Achilles heel. Then there's the ball check. Its design is really clever. It's self-cleaning, making it perfect for thicker fluids you find in chemical plants. And then you have the really advanced stuff, like the magnetic valve. No springs to wear out, so it's basically maintenance-free. That makes it perfect for super clean places like food processing or pharma, even though it costs a bit more upfront. Each one is a tool for a specific job. But let's circle back to our villain for a minute, because to really appreciate our hero, you have to understand the raw, destructive power of the shockwave it's designed to fight. The whole process is just brutally simple. You can see it laid out here. First, you've got fluid just racing through a pipe. Then, a valve slams shut. Instantly. All of that momentum has to go somewhere, and it immediately turns into this massive pressure spike. That shockwave then just blasts backward through the whole system, hammering pipes, joints, sensors, everything. And I'm not being dramatic here. The experts over at DFT Incorporated put it bluntly. The force of this hydraulic shock, they say, can be extremely destructive. We're talking ruptured pipes, broken flanges, and totally wrecked equipment. But here's where the story gets a crazy twist. What if I told you the hero was sometimes the villain? Yeah, it turns out that the most common, oldest type of check valve, that swing check valve we just met, is often the very thing that causes the water hammer it's supposed to prevent. So how is that even possible? Well, it's all in the design. A swing check valve literally has to wait for the fluid to start moving backward before its disc gets pushed shut. That means it only starts closing after the problem has already begun. By the time it finally slams closed against that wall of reversing water, it creates that exact abrupt stop that generates the water hammer. And the consequences of this kind of failure, they can be staggering. When you factor in downtime and lost production, a single valve failure can easily cost a company thousands of dollars. per hour. The stakes are just incredibly high. So, if the common hero has this fatal flaw, what do? Well, it meant engineers had to go back to the drawing board. They had to outsmart the physics of the problem. They had to design for silence. And the answer they came up with is just a brilliant evolution in the technology: the silent check valve, sometimes called a non-slam check valve. The key difference here is all about the timing. Instead of being reactive and waiting for backflow, a silent check valve is proactive. It has a spring inside, so the instant that forward flow stops, that spring pushes the valve closed before the fluid can even think about reversing. The disc only travels a tiny distance, and it closes gently, silently. It doesn't just stop backflow, it prevents it from ever starting. It's a total game changer. And you can see a few examples of these advanced valves here. They really are these little masterpieces of precision engineering, designed from the ground up to be proactive instead of reactive, and to eliminate the problem at its source. So, what's the big takeaway from all this? I think it's a powerful one. In our vast, complex world, it's often the smallest, most overlooked, unseen components that have the biggest impact. A simple design choice and a tiny valve can be the difference between a silent, efficient system and a catastrophic failure. And that really makes you wonder, doesn't it? What other invisible heroes, what other elegant little pieces of engineering are out there right now, quietly and flawlessly doing their jobs to keep our whole world running?